Hello, this is AMAT 104, lecture recording week 10.2. So today we're basically going to spend time going over different formulas and different definitions that's going to be in the second exam. And second exam is from, you probably have already received an announcement regarding second exam, but it is from 15.1 all the way to 16.2. So it's not a cumulative exam. It doesn't include the things we've already done in the previous exam. So before, yeah, that's it. So let's actually start with 15.1. So 15.1 was simply graphs. So, and we just learned different types of representing data, and we didn't really have much calculation. So here you basically learned how to go from frequency table and to and from bar graph, or pictogram. We also learned how to go to pie graph, like this. And those are all the things we've actually done. There were no serious calculations or computations involved in there. Likely you are not going to have anything like this in the final. It's nothing really, I don't want to say important. It's nothing too difficult, and really exam worthy problems will be in the 15.1. But the one thing that you will have to understand is that you should be able to read and understand when you're given a frequency table and like how to interpret the numbers in there. And as long as you know how to do so, you're pretty much fine. So the calculations actually come on 15.2, and this is when we did the mean and different percentiles, mean, median, and percentiles. So the mean or average, so mean slash average, is actually simply D1, D2, all the way to dn, and you're dividing it by n. And here, obviously, this D1 implies it's a first data point in the data set, second data point, nth data point. And here, this n is the size of the data. But in a frequency table, you're often given things like this. You're often given, so frequency, let's say value and frequency. And you're given things like, for the first point of the data, you have frequency 1, data 2, you have frequency 2, and all the way up to, let's say, data k, all the way up to frequency k. Then how you find the average is by 3 steps. So you first find the sum of all the data, and how you do that is you simply multiply the D1 by F1 plus D2 by F2. So you're simply multiplying the corresponding data to the corresponding frequency, and all the way up to dk multiplied by FK. And you also find the size of the data. And how you find the size of the data is simply by adding in all the frequency. This way you can actually find the size. And lastly, you can find the average, which is simply taking the first value, the sum, and dividing it by the size of the data. And when you're given a frequency table, this is the way to find it. Essentially, they're the same thing, but when you're given frequency table with a lot of different numbers, this is going to save you a lot more time than this, but they are essentially the same thing. Next thing we did the percentile. So how to find the pth percentile. So the first step was you find a locator, and that's simply p divided by 100 multiplied by n, the size of the data. And there are two different outcomes. If L is a whole number, then the pth percentile is DL.5, which is simply defined by the L and the L plus 1, so meaning the next value, and you're dividing it by 2. And if L is not a whole number, then the pth percentile is DL plus. In other words, this is the is the value that's rounded up. And make sure before you do anything like this, you have to sort the data in ascending order. So you have to go from the smallest to the largest, and you first have to sort the data like that before you can actually do the locator and find all these numbers. The next thing we did here was the quartiles. And simply the quartiles is a different form, a specific point with the percentiles. So we have the first quartile is essentially the 25th percentile. We have the third quartile, which is essentially the 75th percentile. And we also learned that the median, which is often denoted as the capital M, is simply the 50th percentile, or the middle value. And we also know what the minimum and maximum is. Minimum is the smallest value. Maximum is the largest value. So min and max. Then when you have all these 5 numbers, this is called the 5-number summary. You can simply draw a box plot. And that is, you first draw a number line, and there is a rectangular box and whiskers extending from each side of the box. And there is a middle line like that. And this is the first quartile. And this corresponds to the third quartile. And this is the median, the minimum, and the maximum. In the exam, obviously we're doing this on Pearson, so you're not going to be asked to draw one, but you may be asked to interpret one or choose from multiple choice problems which is a correct drawing of or a correct representation as a box plot. So that was the end of chapter 15.2. And 15.3 is simply we learn the range and standard deviation. And the range, often noted as capital R, is simply the difference between maximum and minimum. And the next thing we did was the interquartile range. Often we say I, Q, R. And that is simply the difference between the third quartile and the first quartile. We should know that the range, because we're taking the difference between the minimum and the maximum, it contains 100% of the data. And interquartile range, it's containing from here to here, and it's simply saying it's a middle 50% of the data. The next thing we did was standard deviation. And simply the standard deviation is a measure of deviation from the mean. It's really saying, it's basically standardizing the deviation, and it's a measure of how scattered the data is. So it's a measure of how scattered the data is. The formula itself is a little too complicated. You may actually be asked to how to find, you may actually be asked to find one or two standard deviation. Nothing too complicated, but here's a formula. X minus the average squared divided by the size and everything squared like that. And I know this may not make a lot of sense to you, but simply if A is the average and you have data points x1, x2, x3, dot, 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 like that, and I guess all the way up to xn. Simply what you're doing is it's always easy to draw a table like this. So you first column, you draw the x and x1, x2, x3, dot, 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 xn. So you're simply labeling the data that you have. And knowing the average, we can simply find the difference. And this is called deviation from mean. So simply the first column will be x1 minus a, x2 minus a, x3 minus a, all the way up to xn minus a. And in the third column, you're simply squaring each value from the previous column. So from here, it's simply x1 minus a squared, x2 minus a squared, x3 minus a squared, all the way up to the last value, xn minus a squared. And now we have the squared deviation. What you're doing is the sum of all these things. So you're simply doing the x1 minus a squared plus x2 minus a squared plus all the way up to xn minus a squared. And simply you're dividing this by the number of the data or the size of the data set. And in this case, we call this a variance. And simply now we know that the standard deviation, the sigma, is equal to the square root of the variance. Meaning you simply put the square root on both sides, and this is how you find the standard deviation. We have actually done a few examples regarding this, and the reason why I do not do any specific examples during these review sessions is because we do not really have a lot of time to go over all different types of examples. And it would not make sense to go over a couple things but not the other things. So if you need practice problems, all the problems are available on Pearson or the e-textbook that you can access from Pearson. And in the past lectures, I have gone over different types of examples. So your best study guide is really the homework problems, quizzes that we've done so far. Okay, so that was actually the end of chapter 15. And after then, we went on to chapter 16.1. And this was also a lot of definitions, but not much calculation. Here we learned the random experiment, sample space, and event. And here the sample space. Simply a set of all of its possible outcome. And the sample space actually depends on the observer. On the observation, let's say. that being said, what it means is that if you are tossing a coin, if you are really interested in what came up, if the heads came up, if it came up tails, you're recording H or T like that. But in other words, if you are observing, if you're more interested in the number of heads that came up, then you are counting either 0 or 1, things like that. And simply the event is subsets of sample space. And what that means is that it simply anything that can come out of the sample space, it can be called an event. Even the sample space itself can be an event. So in the exam, if you're given a problem from here, as you've already seen from homework problems or the quiz problems, you're not really, most problems that you'll see on chapter 16.1 are multiple choice. So it'll be the same way in the exam as well. So you, as long as you understand what the sample space is and which one it is given your choice, then you're really okay with this chapter. Lastly, we went over chapter 16.2, and that was the last chapter we went over, and it is about the multiplication rule, permutation, and the combination. And simply, let's talk about the multiplication rule first. So the multiplication rule is simply as such. So if there are m ways to do, let's say, an event x, and n ways to do y, then there are m multiplied by n ways to do x and y together. So probably the memory on this multiplication rule is quite fresh because we've just done it a couple lectures ago. And the just remember the ice cream examples to see how many different ways you can order an ice cream and a cone combination, things like that. And we have used the multiplication rule in so many different applications, especially in the last lecture where we went over different examples. And multiplication rule in this case is a very important topic here. After then, the chapter we went over the permutation and combination. There probably won't be a question that's specifically asking for the usage of permutation or combination, but it is important that you understand what it is and the applications of it, because you may actually be asked if this is a permutation or combination, things like that. Permutation. So permutation is an ordered selection of R objects from N objects. And the formula is simply NPR, and it's simply n factorial over n minus r factorial. So here, permutation is simply, you can think about an example where we were doing horse example, like which out of 10 horses, how many different ways that we can avoid the first, second, and third place, things like that. Or if we had 30 committee members and we want to elect, let's say, a president, vice president, treasurer, and secretary, that means we need to select 4 people out of 30 people. But because we have labels for each position, that's when we use the permutation, because the order matters. Who comes first, who comes second, always matter in that sense. And combination is essentially the same sense, but it's simply unordered. So combination is unordered selection of our objects from n objects. And the formula goes like this: NCR, and that's n factorial over r factorial n minus r factorial. And here, combination, we actually have done more examples regarding combination. We did the combination in terms of, so we also did the ice cream example. A lot of the ice cream examples we did were combination. Also, when you were selecting just 4 members out of 30 committee members without having labels, without having president, vice president, treasurer, or secretary, like that, if you're simply selecting 4 people out of 30, this is what you use as a combination. So here, I guess the last thing I want to mention is that the factorial, the sign is called the factorial. And it's simply basically if n factorial is given by n multiplied by n minus 1 multiplied by n minus 2 multiplied by all the way down to 2, 1. So for example, if you have 4 factorial, excuse me, if you have 4 factorial, that's simply 4 multiplied by 3 multiplied 2 plus by 1, and that's 24, and so on and so forth. So anything like this. So in other words, in order to calculate, let's say, combination, let's say 30 combination 4, you would have to do 30 factorial divided by 4 factorial multiplied by 30 minus 4, which in this case 26 factorial. And you would just have to plug this into calculator. And oftentimes in the calculator, you should be able to use a function that's designated for the factorial or the combination or permutation. So you really shouldn't have to calculate all this by hand. So I think I'm going to end here, and you probably have already received a detailed email or announcement through Blackboard regarding the second exam. So if you haven't already checked, please go do so. And I think I'm going to end it here. So have a great rest of the day and good luck with the exam.